Hello, I'm finally getting back to doing another video. I haven't done anything for quite a while now because of illness, and I've recently, in the past week and a half, I've actually got back to doing some work on this cross slide, removing excess material before I try to finish off with a CNC program to make this thing, or finish it to a shape like this. When it's finished, of course it will be up that way on the bed of the base of the shaper. I'll turn the camera around so that hopefully I can show you the base. This is a 2-inch block of hot rolled, I would imagine, that I put T-slots in. This is going to be the base, and this is the other half of the piece that is on the milling machine. And if you can see, that would go on there like that, and I have an awful lot of material that I've had to remove to get to where I am at the moment. So as you can appreciate, it's taken a long time on the little tag to actually remove most of that material. I've got the top, the side dovetails finished, the top is finished, the recess or the trough along is finished for the lead screw and the automatic feed, cross feed. And now I'm actually milling all this chunk off of here, and it's been a long drawn out saga. I guess you could call it a saga, but I'm gradually getting down to the finish, and I'll be glad to get this off of here so that I can concentrate on some other little jobs that I want to do, some other projects. I don't doubt that a lot of people, if they look at my channel, they've got fed up with seeing this thing stuck on the machine. Okay, I'll turn it round again, and I'll get that on there like that, like that, and so that's what the finish is going to be like, around about that size. And that across the 2 points is 3.5 from that tip to this edge. 3.5 inches in measurement, and the trough is just under 1 3/8 inches. And so this was just a sample that I cut out of a 1/4-inch plate, aluminium plate, to give me some kind of a reference to where to rough this off. And you can't see it, but I've got a thinner one at this end wedged up against the cast iron and wedged with one of these clamps. So that's what I'm working on. So I'll start the mill up. This is 11. I've got the travel at 11.4 inches total from this end to this end. That's just about the maximum of the Tague mill. You can't get much more, I don't think, without this end coming too far into the y-axis. I've got a 3/8. I have a 3/8 single tooth carbide insert cutter, 3/8 diameter, and it's just a Chinese product, and it's doing the job. So for, I don't know, maybe 20 bucks, I got the cutter and 10 inserts, so it seems to be doing it okay. What I'm doing now is, when I start it up, I'm going to drop it. I've already got it set. I've dropped it down. I'm taking 25 thou deep cuts along, and you'll see the type of feed that I have on there. I've got it running at about 1100 RPM. Don't know if that's the right speed or the feed. It seems to be working okay. The insert has a 0 positive form, so it's kind of pushing it off, which is kind of ideal for cast iron. And so it's a bit rough at the moment, but eventually, once I finish removing most of the material, I'll put this other template up and clamp that at this end, and then I'll put a round nose tool, a 1/4 inch bull nose carbide, and start to whittle away the high points and use the template as a gauge, and then maybe the CNC program will finish it off nicely. So I'll start the machine up, and I'm using Mach 3 control, and the system that I have is an old, I bought this probably 10, 12 years, at least 12 years ago. It's a Camtronics. Dan Morsch, I think, is the designer of this CNC stepper unit, and I bought the Italian motors as well, the steppers, for a package that was quite expensive then. Of course now it's an awfully lot cheaper, but the system is working okay. I have a little bit of a problem with the Mach 3 stalling sometimes, stop cutting and then pick up again. Sometimes it just jams, and so I have to keep an eye on it. It's not a kind of a situation where I can really walk away and leave it. So okay, I do it in 2 steps. I do a run, a pass up this way, and then I put on another 25 and do a pass back down again. So that's what I'll do now. Okay. So got everything ready. So here we go. could take maybe a deeper cut, but I don't get too much vibration from the motor up here, which means that the Z column is pretty sturdy. I think a lot of it, I haven't had it where this thing has been shaking up the top here quite a lot, and I've got this dovetail, tapered dovetail, not dovetail, a tapered dowel that I put in between the two round sections there, right down through the center. So I think that is helping to keep the column upright and not moving under a heavy cut. But that's only my theory. I just feel a bit safer having that there. If I want to move the Z column, I can just withdraw with the extractor screw there, I can just withdraw the tapered dowel and just pull it out, and then I can swing the axis, the Z axis. But with CNC, you very rarely need to have to move the Z column. So it's good to get back in the shop and get things going again. It's been about 3 months that I've had a few problems health-wise, and so it's good to get back and even feel that I want to come out to the shop. One of the projects that I have in mind is to install a screw cutting system on the TIG lathe, and I've been looking at Nick Carter's website, and I've been studying the one by Mr. Brooks. So because of the design that I already have on the TIG lathe, it means that I may have to adapt a little bit differently to Mr. Brooks's design, but it's going to be close to that kind of system. So that's one of the projects I have. I've got several other that I'd like to do. Switch the controller, wind out, wind down, 25. I guess it's taken about maybe a quarter of an inch, no, maybe 3/16 wide cut. I have been taking a full 3/8 wide cut, and it seems to work pretty good, considering the fact that it's such a long job, and it's almost at the limits of its travel. So I think all in all it's a pretty good little machine. dirty stuff, this cast iron. Of course, this is this billet. You can see this billet here. As you can see, it had a core down, an open core down the middle. I got it in Calgary. Very, very hard to find cast iron here in Canada. I don't know what the problem is, but even the metal supermarket stores, they don't seem to stock cast iron. And I had an awful time trying to get some, so I eventually found this foundry that was building, doing castings for the CN Railway or CP Railway. And they had a whole pile of these outside in a box, all rusting away, and they were in terrible shape. And I'm sure it's not the best of cast iron, so that hasn't helped. That hasn't helped the machining process. But there you are. That's all I could find at the time. So. The trouble is that at $1.37 for the US dollar and the bloody shipping, it really causes a big problem for the pocket. The pocket suffers a lot. Not much fun when you have to pay $1.37 for an American dollar. It's about, for every $10, that's another, what's that, $3 on top. So $10 US is $13 Canadian, or somewhere around there. So when you start looking at cast iron at $100 a block, plus shipping, something like that could cost you anywhere, I don't know, 200, well, the whole cost could be probably $200 US, which is, what's that, that's about 260, $70, something like that. You know, $70 on top of 200, that's quite a nice little profit for them. So, I'm getting down to the taper here. This taper here, this dovetail. You can see that. Yeah. So I'm getting down to this dovetail. Close to it. I got about maybe another 1/8 of an inch to take off. Maybe 200. So it's taken ages. the video off now. I think you've seen enough to know that I'm gradually getting down to the finish of the roughing out. So I'll call off now, and I'll get back to you again when I'm further ahead. Thanks for watching. Comments are welcome.